Current source applications. Current source circuitry is widely used in industrial control systems. Current, rather than voltage, is used to transmit analog measurements over long distances. Current transmission has advantages over voltage signals. The current is not affected by the added resistance of long wiring. Also, current signals are less apt to be affected by electrical noise or electromagnetic interference, EMI. Industrial two-wire transmission. In industrial applications, an elevated zero signal with a current range of 4 to 20 mA DC is typically used. The elevated zero signal means that 4 mA represents the low, typically zero end of the range. The high full-scale end of the current range is 20 mA. For example, 4 to 20 mA might represent 0 to 250 degrees from an angle position sensor. Figure 1 shows a typical 4 to 20 mA industrial current communication system. Current source and LED drivers. LEDs are often driven by current sources. As mentioned above, 1, 2, or several LEDs can be wired in series, and the current will not change. The current sources usually are specialized LED driver ICs, not simple circuits you can design yourself. Often they use pulse width modulation, PWM, to maintain efficient operation with changing loads and supply voltages. Many are available with varying features for different applications. To learn a bit more, here are links to a simple IC from Diodes Incorporated and one from onsemi. Current sources in integrated circuits. Current sources are also used in the internal circuits of ICs, especially analog circuits. The current sources are also referred to as current mirrors. Popular current mirror designs include the Widlar current source, named after the legendary analog designer Bob Widlar. How to design a current source? Take a look at Figure 2, which illustrates a simple one-transistor current source circuit. Due to the base emitter voltage drop of the NPN transistor, the emitter voltage is about 0.7 volts below the base voltage, VB. The emitter current, E equals V/R. The collector current will be constant, approximately equal to E, regardless of the voltage on the collector. Overall, it will be roughly 1% lower due to the slight current drawn through the base. The circuit is sometimes called a current sink because it draws or sinks current from the supply. To change it to a source, replace the NPN transistor with a PNP transistor and turn the circuit upside down, connecting the minus output to the common. If VB is variable, E and EC will vary proportionally. Figure 2 also shows two possible fixed voltage sources. The one using two resistors will vary if the supply voltage varies, causing the current to change. The Zener source will remain constant despite supply voltage changes.